Hello everyone, you're welcome to the second phase of the AI in Civil Engineering course. In the first episode, we simply downloaded the data and then we cleaned the data. And what we did exactly in cleaning the data was to look for missing values. If we had any missing values, if we have any duplicate values, we dropped them. We identified 25 duplicated observations. And then we also diagnosed for outliers. We used two methods. We tried the IQR method. We obtained 91 outliers. And then we also checked for we used the Z-score method and we obtained 49 outliers. We eventually implemented the IQR method and we have about 1,009 observations now. So we came down from 1,030 observations to 919 observations. And the name of the data frame is clean data. So now that we have the clean data, the next step will be to explore further the data. So what exploring the data means, exploratory data analysis, EDA, what it simply means is that we want to understand data. We want to see the skewness, the distribution, the correlation, the information that we can get from the data. We simply just want to understand the data further, because cleaning the data is one thing, understanding the data, exploring the data is another thing. Okay, so now we need to do that. The first thing that we do is to split the data, the cleaned data. We need to split it into feature and target. I will simply assign a name to it. Don't forget that the data is called clean data. Remember, the data that we have now in 19 observations is called clean data. So I'm simply just assigning it to a data frame called DF, because it's quite easy for me to say DF, that is a clean data. So it's okay. Then now I will split them. I will say X equals to DF. Okay, actually it will make sense for me to simply drop the targets, because targets is just one column, so I can write that easily. So I would say drop columns equals to strength. In cases where you have more than one column, you can just put this in a list, but of course it's just one column. And then my target will simply be, well, I cannot drop 8 columns in this case. It makes sense to just select that column. So I will do indexing and then I will select strength. Then I will run this. Now I have splitted my data frame into feature and target. If you still remember, feature means input, right? And target means output. What we are looking for as the output is the strength. What we want to calculate eventually is the strength. Other stuff like cement, water, they are just inputs to determine what the strength is. Okay, now we go to the next step, which is the skewness. Well, in skewness, we are trying to understand the data, if the data is normally distributed or if it is positively skewed or negatively skewed. That's what we're basically trying to do with skewness. So if you calculate the skewness and you have a data and you have a value of, let's say, 0 or something closer to 0. When I say something closer to 0, I'm saying something in the threshold of minus 0.5 and 0.5. So minus 0.5 and plus 0.5, something in that space, we can call it normally distributed. But if you go beyond that threshold, then it is either positively skewed or negatively skewed. Okay, so to do that, I will check the skewness of the feature. So I'll say x.skew and then I just run it as simple as that. So you see for cement, we have something greater than 0.58. So this is positively skewed. Blast furnace, also greater than 0.5. So I would say this is positively skewed. This is less than 0.5. I would say this is still in the range of what I can call normal distribution. This is also closer to 0. I can call it normal distribution. This, they are also normally distributed. And this obviously is greater than 0.5. So this is highly positively skewed. Okay. What you could do is you can sort the values. I can say ascending equals to false. So instead of not having them in orderly manner, now I'm going to have the biggest number at the top, then it will be arranged in ascending order. So something like this, but based on value. When you want to sort, you can either sort by value or sort by index. But in this case, I am not concerned about the index, I'm more concerned about the values, all right? Then the next thing will be to also check for the kurtosis. I can simply copy this code and just change this method from skewness to kurtosis. Yeah, we have something like this. You would see that in both cases, age comes first. It has the highest skewness and the highest kurtosis. But these are just numbers. I'm sure when you're looking at number, you have to do a lot of processing in your head and say, okay, if it is 0, it's like this, that kind of thing. The best way is to plot them and visualize, okay? So now we will try to visualize. We want to plot all of them, the feature, the targets, and we have to have each histogram for each column. So to do that, I will possibly need to use because it will not make sense to plot them one after the other. We can just use a for loop and plot all of them together. But first thing first, I will create a figure on the axis. Then I will do a subplot. I will do a 3x3 grid. Then the fig size, I will just do something squared. So 12x12. I will also flatten the axis. Then I will write the for loop for, okay, let's do it this way so that you understand it better. I'm trying to make this code as simple as possible. So if you have a data frame can be split into 3. You can split it into the index, the columns, and the values. For example, if I say df.columns, this will just give the name of each column, the header of the column, cement, blast furnace, the header, right? You could say df.index, and then it gives you the index from 0 to 919, right? If you want to see the values, you could say df.values, and that shows you just the values. Okay, so in this case, I am more concerned about the name. Why am I concerned about the name? Don't forget that whenever we want to do an indexing like this, we usually say df, then we bring these brackets, and then we call the name. So instead of typing cement, blast furnace, fly ash all of the time, I can try to just, make use of df.columns, So I will do that. And then also, you will realize that whenever we are plotting a subplot, we usually need the index of the axis to simply identify if I want to plot in this axis 0 or in axis 1. Okay, so I also need the index. So I need the index and I need the name of the column. So I will use enumerate. Enumerate looks like the best option to use here. So I will say df dot columns, right? So I will say for index for I and the value in enumerate, okay, and then sorry, I should place it here. So I will say sns dot histogram, sns dot histogram. The first one will be df, and then the name. Okay, I think I'm jumping. I remember what I was trying to do here. I was trying to explain what enumerate does. Okay, so in here, if I print I and V, which is the index and the value, we have something like this, which will return the index and the name of the column. Okay, so in this case, I can, if I want to grab, let's say, 0, I just need to print I. Okay, I can simply say print I, and it gives me the index alone. If I want to print the value, I can simply say, V. So this is the concept of what I am trying to use here when I'm plotting my graph. Okay, so I will bring this here. So for the index and the value, I will simply say SNS, which is Seaborn dot histogram, histplot, and then I will say df, then cement. For example, in the first iteration will be cement. So in this case, I will not call cement, I will call V. Okay, I will say V. Then the next thing I want to do, because this is an Instagram, when you're doing an Instagram, you need to identify the bin. Okay, the bins, the number of bins. So in this case, I can simply say, let's say 30 bins, or you could use something greater than that. I also need to specify the axis. The axis will be the index. So instead of saying 0, for example, I will simply just say I. Okay, so I will say I think what else can I call here? I mean, you can decide to do some other stuff, but let's just move on. Then I will plot the title. So I will say axis. Instead of calling 0 in the first iteration, I will say I, right? So xi dot set title, and then now in here the title I can say cement histogram, but instead of saying cement histogram, let's do something like this. I mean, for the first iteration we would say cement will be what? Cement will simply be V, right? So I will use this V. So this will be cement, so I can say cement histogram for the first iteration. Then the second iteration will just be blast furnace, fly ash, water. I mean, for the for loop, because the for loop will first of all run the first iteration, then it goes to the second, then it goes to the third until it is done. Okay, so this is simply what we need to do. And then the next thing I will do will just be, I can say plt dot type layout, and then plt dot show. Okay, so I will run this, and now this will plot all of them for me one after the other. You can see with just this for loop of 3 lines, I don't need to separately plot this, plot this, plot this, plot this, so simple like that. Now to understand this, you would see that the the line goes like this, something like this. What we could do here, we can plot the KDE, which is the Kendall density. So KDE, I will say KDE equals to true. So that will give me the line. Now you would see that line. So in here you will see. So let's check for cement. As we saw here, the skewness of cement is 1.2. As I said, it is positively skewed. And then you see that the tail is longer to the right. So this confirms that it is positively skewed. If you check for the blast furnace as well, it has to be positively skewed. So let's see the blast furnace, you see 0.8. This is also positively skewed. Let's look at something that looks like a normal distribution. Let's say fly ash. Fly ash looks like a normally distribution. You can see that the peak is somewhere around the center. In here is, although it goes up, there is this kind of like outlier, kind of. But then you see that this is at the center. If we look at this, let's say for example, the coarse aggregate, this also looks like a normally distributed. Let's look at the skewness of coarse aggregate. You can see this is very close to 0. If you check for water as well, you see water is even the closest to 0. So this will look more like a normal distribution curve. So let's see water, you see, it looks like a normally distributed curve. So the tail here and the tail here, they are kind of like the same. And then, the peak of it is at the center. Also, if you check for the fine aggregate, you see this also looks like a normally distributed curve. So if you check for fine aggregate, right? So what is this for fine aggregate? For fine aggregate, you see it's also 0.28. So something in that threshold of plus 0.5 and minus 0.5. Okay, so this number, it makes sense if you understand it, but then it's still better to visualize. So, I like to visualize to see for myself. Okay. So I will delete this. This was just to understand how we are enumerating and using the loop. Then the next thing to do now will be to have the bivariate distribution. What I mean by univariate distribution here is that I am plotting just one column against the number. I'm not plotting something against something. I'm simply just plotting cement. So it's a univariate distribution. I'm simply checking the distribution of that column alone. Okay. So for the bivariate distribution, I am trying to compare the feature against the target. So what I will do now is that I will check what is the relationship between cement and strength? What is the relationship between blast furnace slag and strength? What is the relationship between fly ash and strength? Okay, so I'm trying to take all of these one after the other and compare with the target. Okay, so this will allow me to see that, okay, this particular feature has maybe a linear relationship with the target. All right, so that's what I mean by bivariate distribution. I think we can use the same loop here. The way we looped this, we just change from histogram to scatter plot. So I will paste this and then we will see what to change. First of all, we will not have up to 9 graphs, we will have 8 graphs, because in this case I am plotting the feature against the target, so it will be 8, right? Because the target will not stand on its own anymore, so I will have 8. So it doesn't make sense for me to use a 3x3 grid. I can simply use, let's say, 2 rows, 4 columns, okay? And then let's make this 12 by 6. I will flatten as usual. I will say for I and V instead of df, I will be using x, which is feature, okay? And then sns.eastplot, this will be sns.scatterplot. Okay, for a scatter plot, obviously you need two arguments. You need the one that will be on the x, the one that will be on the y. Okay, so this is my x. I will say x equals to, instead of df, I will just simply change this to x, and then I will have y. My y is simply y. What I mean by y is simply y is because here we called our target y. Okay, so this is the y here, and then this y is a variable, and this one is just a statement. Okay, for example, if you do shift tab, you will see that it says x, y. So the x that I have here is this x, and this first y is this y. All right, and this second y here, this one that I'm assigning, is this y over here. Okay, so don't get that confused. Then KDE, I don't need a KDE because this is not an histogram, so I'm going to take even this as well. Okay, so I think that makes sense. Then yeah, so I will call this scatter, or maybe scatter plot. Okay, then I can simply just run this. Okay, so we will have the scatter plot of each feature against the target. So this is a plot of cement against the strength. You know, on the y-axis, y equals to mx plus c. Y is the output, so y should be on the y-axis, which is the strength, and the cement. So if you look at this, you can kind of establish the relationship between, let's say, cement and strength blast furnace and strength. Let's try to take a snip of this. Okay, so what I'm trying to do basically here is that do you think we can identify a linear relationship between these? You know, for example, if you draw a line that starts from the 0 and goes like this, yeah, maybe this is somewhat linear, all right? But how about this? I don't think this is linear. Maybe. How about this? Well, maybe a line that goes like this. What about this one? Again, this looks like a constant. You know, it's just constant here. All right. So maybe something linear here as well. A little bit linear here, but we still have constant. You know, if we fit a linear regression here, how much can this, can this catch? So this will take us to the next step where we have to like discuss the relationship that each feature has with the strength. Is it a linear relationship or it's not a linear relationship? So we can check the correlation. What we mean by correlation is that we are trying to see if there is a relationship, there is a linear relationship between the target and the feature. So say for example, when cement increase, does the strength increase? Or when the blast furnace slag increases, does the strength reduce? You know, that kind of relationship. That's what we'll be checking with the correlation. So we will see that in the next video.